Hi everybody. So we're going to try and unpack and do a little overview here of the foam nest project that we completed to hold this plate upside down for carving the interior. Now you may remember that we started out testing the process and materials with using a glass plate because it was easy and quick, and we did a couple of experiments with this quick tool which we cut out and threw away and tried again a couple times. And just briefly, this is the brand that we ended up using. It's a 1-to-1 mix, and we found that it actually expanded less than, it seems like it expanded less than they suggested it would, which of course could have to do with the product age, you know, the shelf life. We opened it once before to do this, before we did the real one, so maybe it got a little moisture in there and slowed it down. I don't know. Here's another kind. This is a 4-pound foam, and maybe we should have used this for this project, but at any rate, this stuff is available in a lot of other kinds and styles from different manufacturers, and it's used in very light density, like this 2-pound. So this 2-pound means it's 2 pounds per cubic foot, so that's not a lot of weight for a whole cubic foot. For example, spruce is about 30 pounds per cubic foot, and we think of that as light. And maple, say, is usually something like 45 pounds per cubic foot. So in the past, I've used this kind of 2-part foaming stuff in higher densities for different jobs. And the kind that I like the best, I no longer remember what it's called, but I know it came from Germany, and it was designed to be used for making prosthetic limbs. So those are supposed to weigh about as much as a person, I guess. Anyway, so that's there's more to know about this that I don't know, but we got the result we wanted. One more thing before we get back to work, and that is, I've had a couple emails from people wondering if this kind of support idea could be used to support plates that were in repair. And one person wrote in talking about cello-sized plates. When those plates are removed from the instrument, they're large and fragile, and the standard way that people support them is by pouring a plaster cast. And in order to do that, you have to make quite a large structure with like a little swimming pool so that you can pour the plaster over the plate, and it takes a long time to cure properly. It's very heavy, easy to crack, and the good news about it, the good thing is that if you cast a part that's been distorted over time by forces from the strings, and the plate is deformed and needs to be kind of pushed back into its original position, well, you can go in there with a scraper after the plaster has properly cured and renew the surface and get the surface just the way you want, so that then you have a mold that you can try and coax the top or back into shape in that mold. Anyway, this person was asking whether this could be used instead of the plaster, which, as I just said, has a lot of issues and problems. And I suppose you could do it. I think if I were going to do that, I would use a higher density foam and maybe just pour it without a plate on top. So in other words, imagine that this was a guitar top that was distorted. You could build a box around it, pour foam in there, and without restraining it, just let it expand and cure on its own, and keep pouring it up until it filled up to to the level of the box that you built. And then you could figure out a way to maybe straighten it out and then bond a piece of flat material or plywood on top so that you could turn it over and continue to work. So the answer is maybe. And it might be worthwhile trying it out for someone who does a lot of work like that. All right, so let's get back to our tool. So since we have gotten this out of the mold, we screwed down this masonite. I cut a hole over here with a big Forstner bit to give you a way to pick the plate up. We drilled a hole in the center, and we put in a carriage bolt like this that's well below the surface, so this won't be in our way. We had to chisel out a little bit for the square part, but that gives us a nice way to capture it like this with a nut from underneath. Okay, and then of course a lot of little stainless screws around here, taking care that they're countersunk properly and not sticking up. And then finally, we need a couple of hold downs, and you can see here these are threaded inserts. All this stuff came from my local hardware store. This is a imperial thread. It's 1/4 20, and they're a little bit difficult to drive. You can see there's a very thin section external thread, but the easy way to drive it, or the little trick to drive it, is you put a long fastener in here and stick that all the way through the hole, so the fastener will align the insert so it goes in straight. And then, as you can probably see, there's a little slot there, so you can pull down on the fastener to help drive this into the fixture while you turn it in with a screwdriver. So that's that's how that works. Anyway, so those are in there, and again, we put 3 little pads that are going to help us get a good grip on this. So when we put the nut on the bottom of this carriage bolt, and tighten it up, we've got a really solid, rock solid fixture here. All right. All right. So next, the little hold downs that we'll need to control a plate while we're working on it. On my previous nests, I've used these little things that, I made these parts on my lathe, and likewise these little parts I made on the lathe. It seems convenient to have it come off easily like that, but trying to do this from the the regular hardware store point of view. So just got a piece of threaded rod we cut off, and then here's a wing nut with a plastic retention washer that's squished in there that'll keep these 2 parts stuck together, and a little washer, and then the hold down, which is a spacer block, a little slot, and a piece of leather to press on the plate. Okay, so when this is working, this will keep it nice and firm so that it can't jump around, and we can take a good cut on it, because there's going to be a lot of rough work on this plate before we start tuning it up. All right, so all right, so there it is, and Next, we're ready to get in there with a gouge and take some material off the inside.